All right, is everyone here?
Oh, there we go. To turn that on. There we go.
All right, so I think everyone's here, so let's get this started. Hi, everyone, and welcome. Welcome to the first session hosted by the Python community in Sri Lanka. So we are really glad to have you guys here, and we hope that this will be one of the first of many sessions that's going to come in the future. So I'm Jason, and I'll be your host for the evening today. So to kick things off, the first session that we're going to have, today's session, will be themed Working with Text, an introduction to Python strings, and it will be delivered by Mr. Reuven Lerner. I'm sure for those of you who have attended PyCon 2022 that you recognize Mr. Reuven. So he delivered the session titled How to Sort Anything. So for the rest of you, let me give a small introduction on who he is. So Mr. Reuven Lerner is a full-time Python trainer based in Israel and has been teaching Python courses for companies in many regions, including the US, Israel, China, and Europe, as well as people around the world with his online courses. He has a couple of books published under him and is the creator of one of the first 100 websites in the world after graduating from MIT. So welcome aboard, Mr. Reuven, and thank you for agreeing to conduct this session. We are really interested to hear what you have to say. What do you say we get this session rolling?
Excellent. Excellent. I'm very excited to be with you folks. Thank you, Jason. Thank you, everyone, for showing up. And fantastic. So the way that I normally like to teach is I don't like using slides. I like doing live coding. So that's what we're going to be doing today. So I'm going to share my screen here. Let's see. Present to audience. Share screen. Hey, what do you know? Oh, and of course, I need to like choose things. Let's see. Oh, of course. Let's see. Allow. Yes, I just wanted to allow. Oh, I should have like figured that. Hold on a second. Hold on a second. Oh, screen one. There we go. That. There we go. Fantastic. Okay, so you are seeing the right thing right now. So this is my screen, and this is the Jupyter Notebook. Those of you unfamiliar with it, so Jupyter is sort of an illusion. It allows you to believe that you're typing in Python inside of your browser when you're in fact typing in Python inside your browser. No, but then it goes back to a backend system where it is interpreted and then run here. And the really nice thing is I can have this mirrored to somewhere in GitHub, and then you can see it both now and later on. So I'm going to give you here, I'm going to put in the chat here. I think there's a chat. Yes, what would I like to share? Bam. There we go. So if you look in the chat, that is I think everyone can see that. That's the URL of my current Jupyter Notebook. And basically, as time goes on, within 1 to 2 minutes, it should synchronize and be there. So every 1 to 2 minutes, it should update. So let's start with a little bit of an agenda. So we're going to talk about strings in Python. So first, I want to talk to you about defining string. Well, let's talk about what are strings, right? What's with this silly name that we have them? And then we're going to talk about defining simple strings and retrieving from strings. And then we're going to talk about string methods. And then finally, we're going to talk about looping over strings. And I think that should very easily fill. I'm going to talk for about 40, 45 minutes, and then there will be plenty of time for questions. And I hope you will have lots and lots of questions because from my perspective, my job is interesting because people ask questions and I got to try to answer them. It's even more interesting when I cannot answer them, quite frankly, because then I get to learn something. So I am trusting you all to ask me lots of really good, tough questions. Okay. What's this here? Oh, that's like in the wrong place, but fine. Doesn't really matter. I'll just put that away. Okay. Excellent. So let's start with what's a string? and it might seem really stupid to ask this question, but if you say to a person on the street that Python does great work with strings, they will think that maybe Python does knitting. Python is like a seamstress. like what do strings have to do with computers? And the answer is, of course, that strings are for working with text. They're the text data structure. Okay, that's nice, but just what's with this silly word? And the best I can tell, so think about it this way. Inside of a computer's memory, what do we have? We have a number, followed by another number, followed by another number, another number. Anything else is basically an illusion or an abstraction that we've created. And so many years ago, when they started creating computers and working with them, they wanted to deal with text. And they couldn't really work directly with text, but they could say, well, this number is not really a number, it's a character. And this number is a character, and this number is a character. And if you've ever done any C programming, and I must admit that I used to do it a little bit, and I was terrible at it, and so I'm very happy that I have a job working with Python. But in C, you don't really have text strings. You have a character and another character, another character. Well, those characters strung together on a string, like a string of pearls, that's the idea. So basically, a string is because we've strung together these characters, and thus we can have text. And so anytime we deal with text in Python, we're using strings. And that can mean the empty string, right, which is like, this. Or we can have, a character, because there are no characters. There is no character or char data structure in Python. It's just a one character string. I know it seems funny that we talk about characters even though there aren't characters. That's the way it is. We have words, we have sentences, we can have entire files, right? Anytime you have text of any size, it's a string in Python. And that makes it like easy to think about because it's just one rule to deal with all of these different things. All right, so let's like create some simple strings. So now some of you might be familiar with like the shell, Unix shell, or maybe like Perl or Ruby or PHP, or one of those, in which you have differences between single quotes and double quotes. So in Python, there is no difference between single quotes and double quotes. None whatsoever. You can use either one, right? And sometimes one's going to be a little easier than the other. We'll talk about that in just a little bit. Here's the thing, though. Well, as I like to joke, and this is just a joke, but I like the joke, that double quotes use more electricity than single quotes, so you should try to avoid them. No, more seriously, the convention in the Python world is to use single quotes, unless you don't have an option. But like, again, Python doesn't care. It's the rest of the Python community that cares. So basically, I can say S equals A, B, C, D, E. And here I'm creating a string object and assigning it to the variable S. Now, I want to be clear. You could say, oh, S is a string. But let's be a little more pedantic than that. That's a little more exact than that. S is a variable, and it refers to a string. It refers to a string object, because variables in Python always refer to objects. And so if I say, what's the type of S, right? What kind of value is S referring to? And we see here stir, and stir is the way that Python calls strings. Okay, fine. So I can create a string with single quotes, and of course I can create a string with double quotes. What if the string contains single quotes? Right, what if I want to say here, right, S equals, she's very nice. Oh, well, that's a problem, right? Right, this won't work. It won't work on, there we go, and I've got the extra quote in there too. This will not work. Why? Because Python sees this until this as the string, and the rest of this stuff is just junk. And indeed, if I try to run this, it'll say unterminated string literal detected at line 3. Unterminated string literal meaning you tried to enter a string and you did not finish it. So one way, right, solution one is to use \quote to stop Python from interpreting quote as the end of the string. So I can say here, let's just take this example again. I'm going to say S equals she's very nice. And I'm going to say in the middle here, she \apostrophe. And now it works just fine. Right? I can say print S, but watch this. What's the printed representation of our of S? And for that in Jupyter, I can just enter it and watch this. It put double quotes around it, right? So basically, solution 2 is just use double quotes if your string contains single quotes. And that's like a pretty standard solution. So I'll just do this, and then I don't have to worry about backslashes and all that other stuff, and now it's all good. And the opposite is true, of course, also. So, too. So I can say here, for example, S equals, he says, hello. And you can see, like, once again, we're in trouble territory here, and Python's not going to know what to do with this. So what should I do here? Well, of course, I can use a single quote. He says, like that. And now print S, no problem. S, no problem. We're doing great. But what if we need both? Oh, then we really need, to backslash something. Backslash something. So I can say here, for example, S equals, he says, hello, or he says, she's very nice. Right? Something like that. So now I'm really in trouble. Something needs a backslashing, and I think it's going to have to be that. And then I can say print S. But even Python, its printed representation is going to be like, well, like, what are you going to do? All right, so this is how we can create a string. And there are a few variations on this as well. So, variation on string number 1 is R strings. These are raw strings. And what that means is, well, let's do this. If I say here, let's say I'm working on Windows. I know. Oh, triple quotes. Yeah, I'll get to that in just a moment. Thanks for the question. So what if I have this? What if I'm working on Windows and I say path equals C, A, B, C, D, F, G, H, I? I do this. Looks good, right? So now I say print path, and not so good. What happened to the backslash A? Well, Python basically, in a string, let's do a backslashing. So in a string, you can use backslash and then another character for, special uses. Sometimes, as with, backslash quote and backslash double quote, it's to stop something from happening, such as ending the string. But many times, it's to indicate that we have a special character. And we have a bunch of those. We have, for example, backslash n is new line. And we have backslash t is tab. And what's another good one? We have backslash r is new line. Oh, I'm sorry, it's like carriage return. Right? And we have a few others like that also, including, it turns out, backslash a is ASCII 7, aka the alarm bell. So it turns out that in this particular string here, all right, so in this string, basically, I've got backslash a, and Python took that and turned that into a character that we cannot see, but actually we can hear, right? I don't know if I can put this in my terminal. Let's see if this will work. I haven't tried this in a long time. Let's see. I'm going to crank up the volume. Oh, don't do that. Oh, it's not going to. Oh, never mind. Okay, it's not going to work very well. Oh, what if I do like this? And now I'll say here, print path. Oh, yeah, I heard the beep. You won't hear it, but I heard it. Bloop, bloop. Okay, you don't hear it, but it's there, I promise you. So anyway, very exciting, very exciting. In any event, so Python translate here. So what can I do, right, to avoid to avoid backslash a from being turned into, a special character? I can double the backslash. So I can say here, for example, let's just do this, path equals backslash a. Does it matter if I double the other backslashes? No, right? Backslash a needs doubling, but the others, it doesn't matter. And so sure enough, now it's great. I say print path and all is great. But here I say, why work so hard? I can use a raw string, a raw string. If I say here, path equals R, and the leading R means double the backslashes. And then I say print path, and it works. I look at path, and it's doubled all of them, and we are doing great. So the whole point of doubling the backslash is to avoid that sort of trouble. And I would say there are two good places to double backslashes and use a raw string. One is if you're using Windows and you have paths. The other is if you're using regular expressions, which use lots of backslashes. You can really get yourself into trouble in the interpretation of Python, the interpretation of something else. Okay, there are two other special kinds of strings. One of them is, as someone mentioned here in the chat, triple quoted strings. So if I say S equals A, B, C, D, E, F, G, H, I, J, K, L, it's because I want to have, right, can I have new lines in my string? And the answer is no. Here, once again, I get unterminated string literal at line 3, meaning, hey, dummy, you didn't close the string. But what if I want to have \n there? Well, one possible solution is I could say s equals abcd \n efgh \n ijkl. And that will work, ijkl. Right? It worked. And if I print it, new lines. But wouldn't it be nice if I could have something literal there? And the answer is a triple quoted string. What I can do is say s equals, we'll say here, 1, 2, 3, and here at the end, 1, 2, 3. And now Python does not complain. Moreover, I can print s, and we're doing great. Moreover, look at s's printed representation. Look at that. It's just like we had before. So a triple quoted string is what we call in the programming world syntactic sugar, meaning that it doesn't let us do something we cannot do otherwise. It just makes it easier. It makes it easier to digest, like sugar. Okay. Another thing is, this is the best, I saved the coolest string for last. F strings, or format strings, or I've started calling them fancy strings. So watch this. Let's say I say here, I equals 100, and my list equals 10, 20, 30. So I've got an integer, and I've got a list. And I want to print I is, well, watch this, I, and my list is plus my list, plus period. So first of all, let me add a space there. First of all, this will fail. This will fail in a big way. And it'll fail because you cannot add together things of different types. I've got a string, I've got an integer, I've got a string, I've got a list, I've got a string. No way. Python's like, you can't do that. And one possible solution is to do this. Solution. Use stir. So I can say is stir of I. Remember stir from before? Well, stir means string. I can just turn everything into strings. And it works. Yuck. Oh. The other way to do this, a better solution as of Python 3.6, is to say an F string. Oh, I even had the F string there. Haha. Didn't mean to do that. My fingers are so used to making F strings. So watch this. I could say here is curly braces. And inside the curly braces, it's automatically turned into stir. Moreover, it can have any Python expression there. And so I can even do this. I can say I equals 10 and j equals 20, print f string I, plus j equals I plus j. Amazing. F strings are so effing cool. Anyway, so basically I use F strings almost all the time for just about anything because it's so incredibly convenient that I can put these Python expressions in here. Oh, there's a question. Let me see. Oh, there's a Q&A tab. I didn't even know. Is it wrong? Oh, here we go. From Rajitha. Is it wrong to use triple quote strings for something other than documentation? All right. Wow, Rajitha. Congratulations. You managed to provoke one of my real annoyances. It's not you. Don't worry. Don't worry. Many, many, many people have asked me this question before, and it's me against the Python world. Triple quoted strings are a way to create strings. So if you have a string that has more than one line, that's what you're supposed to do. But many people say to me, come on, Reuven, right? I want to have documentation that takes more than one line. So this is, a comment. And so is this. And wow, this is a very long comment. Even longer. And so in other languages, I could do something like, slash, star, star, slash. And then all of this is a comment. But people want that in Python. Now, I'll tell you, my way to do it in Python, especially in Jupyter, but in many editors, is to highlight the region and turn into a comment. And that's right. Every single line is now a comment, hash mark until the end of the line. That is my preferred way to do it. That is what I like to do. But I've met a very large number of people who say, oh, no, we'll just create a triple quoted string. Now, this drives me completely bananas because it's mixing up, as far as I'm concerned, strings and documentation, strings and comments. Now, how is this a comment? It's a comment because basically the Python compiler sees this string. It sees that the string is not assigned to anyone or anywhere. It's not being used. So we might as well just throw it out. So the Python compiler says, get rid of this thing. We don't need it. It doesn't show up anywhere. And so we might as well use it as a comment, right? To which I say, no, don't do that. Now, the thing is, Guido van Rossum, who invented Python, he thinks this is really cool. I disagree. but it's kind of hard for me to disagree with such a thing because, bigger people than I have done this. I see a question here from Hibathul. Hopefully I got your name right there. Where can we use backticks? So backticks are actually pretty rarely used in Python code. It's used actually for repr. So if I say here like my list equals 10, 20, 30, I can actually say here \my list. And no, I can't anymore? Oh, I thought I could. Okay, never mind then. I was sure that you could use it now for some things. No, okay, so I guess backticks are out. Sorry, I was sure they were useful for something, and now I'm completely wrong. So there you go. Don't use backticks. You can use them here in what's it called? In Markdown. That's about it. Okay, fantastic. So now that I've said how we can create a string, how do we retrieve from a string? And so I'm going to say here S equals A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Fantastic. So if I want the first element of this string, I'll use square brackets with an index. So I'll say S of 0. And the first element is numbered 0. Now, this is a long-standing argument in the programming world. So many programming languages start counting with 0. Why? Because it's the first number, right? Why would we waste it? Many other programming languages start counting with 1. Why? Here's a hint. Humans start counting with 1. And it's kind of weird to start counting with 0, as your non-programmer friends have probably told you. So in Python, like in many other languages, we do start counting with 0. It's a 0 index language. So S of 0, S of 1, S of 2, and that's how we're going to get the alphabet here. Now, can I use, I can use a variable here instead. So I can say like n equals 2, S of n. Because as far as Python's concerned, there's no difference between S of n here, where n, n's value is retrieved. It is 2, and we get S of 2, which is then, of course, C. Terrific. I can use an expression. So watch this. I can say len of S is 26. I can say S of the len of S minus 1. What's that going to do? Well, it's going to, this will calculate len of S, which is 26, then 26 minus 1, which is 25. So this is S of 25. And sure enough, I get the final letter there. I can say S of len of S minus 2. Oops, sorry. Len of S minus 2. All this is fine. But actually, why work so hard? I can say S of minus 1. Same as len, S of len of S minus 1. In other words, the final character. S of minus 2, second to final character. And so on and so forth. So you can count from the left with positive integers and count from the right with negative integers. Just from the right, there's no such thing as negative 0, so that's what we get. Someone asked a question. Back. So basically, sorry. By the way, I just saw your question here as well. And yeah, so I guess backticks are not used in Python anymore. I was sure they were. Okay, I'll find out something about that. But generally, they're just not used. So there. Okay, so this is great, and I can retrieve then individual elements. So watch this. I can even do something like this. I can say here. Okay, watch this. N equals 2. Right. Print. Right, I can say here S square brackets N equals S of N. Now, what am I doing here? I'm using an F string, and so inside the curly braces, it's going to give me the value. So I say S square brackets of, and here it's going to show me N, which is 2, equals, and then all this is in the curly braces. It's going to say S of 2 equals C. Well, what if I want to get, let's get some info from the user. So I'm going to say N equals input. Enter, enter a number, strip. And then I'm going to say here, well, we'll do strip in a little bit. And then I'm going to say here the same thing as I did before. There's just one problem. This is going to die a horrible death because I'm going to say 2, and it's going to say kaboom, string indices must be integers. And I'm kind of confused by this because this is an integer, right? No, it's not. What is n? What is the type of n? Type of n is a string. N is the string containing the numeral 2, the digit 2. But it's not a number. So if I want to turn a string into an integer, I need to use int. So I can say here int of n, and that's the integer 2. And notice the difference. We see quotes over string, and we see no quotes with an integer. So let's do this again. I'm going to say here, let's get some info from the user, take 2. And I'm going to say here n equals int of n. And now I can say 2. That's good. And I can say here 5. And I can say here 10. What if I say here 100? Oh, that's too big. That's too big. So I can put in some guardrails. I can say here, if n is less than 0, print only positive numbers allowed. That'll just make things easier. Elif n is greater than len of n minus 1. Let's just do, say, greater than or equal to len of n, print too high. And else I can say print this. So now we've got a little robust program going. Now I can say, 8 or 9. Oops, what did I not get it right? Object type int has no len. Oh, duh, I did len of n. I should have said n of s. There we go. 9. S of 9 is j. And if I say 100, it'll say too high. And if I say minus 1, it's going to say no way. No only positive integers allowed. So cute little program. Not too stabby, not too shabby. All right, let's see if there are any more questions here, and then I'm going to keep going with some stuff. If you can, discuss a little bit about putting a dictionary inside a string format. Well, we can turn anything into a string. We can turn anything into a string with stir. So stir of 5, that gives me the string 5. Stir of 10, 20, 30 gives me the string there. And stir of the dictionary A1, B2, I get this string. Now, what am I going to do with this string? That's another question, right? But I can just run stir on absolutely positively anything, which is kind of a nice thing. Okay. The thing is, what if I say this? Well, if I say, we've still got our S here. The alphabet has been around for a while, and it's a little boring. Let's jazz up the alphabet. So I'm going to say S of 0 equals exclamation point. That's, I think, a good change to the alphabet, right? No can do. We cannot change string. Never, under any circumstances, at all in Python. It is impossible to change a string. And this is because strings are immutable. They can never be changed. Now, you might say, oh, wait a second, that's weird. I'm sure I'm able to. Watch this. S equals ABCD, and then S plus equals EFGH. See, I was able to change the string. And I say, no. That's not what happened. Here, I defined a string and assigned it to S. Here, I defined a new string, the combination of ABCD and EFGH, and assigned it to S. So S now is referring to a different string than it did at the beginning. So don't think that you can change strings, because you cannot. All right, and mutable versus immutable is a really big deal in Python, and you should always, putting the value for a dictionary, got it. But basically, you have to get used to this idea that strings are immutable. You can just never ever change them, and we'll talk a little more about this either later or in the future. Okay, let me just a little more tea. Okay, fantastic. So now, watch this. Let me just take a look at what I promised I was going to do. Oops, no, come back. Here we go. Just look at my agenda, because I see what time we're at. I think we're totally doing fine. All right, string methods and looping over strings. That'll take us to the end, I'm pretty sure. So string methods. So basically, len and input, or I should say len, input, and print are all functions, right? Meaning that we can run them, and they take strings as arguments, and input even return strings. But most verbs in Python are not functions. Rather, they are methods attached to an object. So here's one we can do. So if I say S equals input into your name, I'm going to say your print hello S. So I'm going to run this. And I'm a little on the tired side. I had a long day, so I'm going to fall asleep on the keyboard. I wake up, fall asleep again. Now, this isn't wrong, but it's not exactly right either. It's not what we want. And indeed, the string S is just ridiculous. So I can use the string method .strip, which returns a new string without spaces on the outside. So if I say s.strip, look at that. Now it's my name without spaces on the outside. Have I changed S? No. How do I know that? Because you can't change S, because you cannot modify a string because strings are immutable. But I could do this. I could say strip. That'll work just fine. But here, S has not been changed. Watch what we can do. This is my favorite solution. I just say .strip here. Input returns a string and will run strip on the string. So basically, input returns a string. It's immediately handed to strip, which returns a new string without spaces on the outside, which is assigned to S. So basically, by the time it gets down to the print here, S has no spaces. And now it works just fine. If I want to see S again, we're doing great. So that actually works pretty well. Okay. All right. Well, what other methods do we have? There are lots of string methods. So we can say, for example, S equals A, B, C, D, E, F, G, H. And I can say S dot upper. This returns a new string all in uppercase. Or I can say S dot lower. Returns a new string all in lowercase. I can say S dot capitalize, which returns a new string whose first character is capitalized and all the rest are lowercase. And here, the most useless string method in Python is S dot swap case. Yeah, I know. I'm not sure why anyone would want this either, but there you go. So there are other methods that are actually useful. For example, if I say here, write S dot index of E, at what index can we find the character E? And that's going to be in 5. I can say S dot index of, I don't know, B. But what if I say S dot index of B, C, D? Yeah, it'll find it. It'll tell me where that is located. What if I say S.index of BD? Well, that they can't find. So it's looking for a substring. It's not looking for the characters B and C and D. It's looking for all of them together at once. Well, there are a few other really cool methods we can use. For example, what if I say this? S equals input, enter, enter a number. Let's do this actually. N1 equals this. And I'll say N2 equals input, enter a second number. And I'll even do a strip here. Strip. So then I'm going to say here, print N1 plus N2. Or I could even say, watch this, F string N1 plus N2 equals N1 plus N2. So now what I can do is I can say 10 plus 20, and we all know 10 plus 20 is 1020. Thank you very much. Have a good night. Wait, what? No, this is not what we wanted. This has to be integers. We have to once again turn them into integers. Well, I can do that. I can say here, right? N1 equals int of N1, and N2 equals int of N2, and now we'll be fine. 10 plus 20 is 10 plus 20 is 30. But wait a second. What if I say here 10 and gobbledygook? It's going to blow up. Can't I, protect myself against this? And a simple way to protect is to say, if N1 is digit and N2 is digit, meaning do these strings only contain 0 to 9? And if so, then we'll do this. Else we'll say print both N1 and N2 need to contain digits. So if I say now 10 and 20, it'll say 10 plus 20 is 30. But if I say 10 plus gobbledygook, it'll say, nope, not okay. So is digit, fantastic method for doing this. It's not the perfect method, but it's not a bad way to go about it for starters. All right. Oh, here we go. Got a great name. A great question from, oh no, where'd it go? I just saw it. There was a question about, I just saw it before, about less than. Well, I'm going to answer it anyway because I really like the question. So someone was asking, I can compare strings, right? So I can say here S equal, well, let's do S1 equals ABCD and S2 equals ABCD. So is S1 equal to S2? Absolutely it is. Yeah. What about this? S1 equals ABCD and S2 equals EFGH. Is S1 the same as S2? No, clearly it's not. Is S1 less than S2? The answer is yes. S1 comes before S2 in the dictionary. How about this one? S1 equals ABCD and S2 equals XYZ. Is S1 less than S2? No. What the hey? Well, basically, all capital letters come before all lowercase letters in these comparisons. And that's a historical thing that basically back in the days of ASCII, which was, even invented before even I was born, and that was like in dinosaur times. So basically, all capital letters come before all lowercase letters in ASCII, and that continues in Unicode. Oh, I'm sorry. There are more questions here. I didn't even notice that. Oh, I'm sorry. I'm getting this wrong. Okay, if strings, so sorry. Sahara, if strings are immutable, why can't we use stir1 is stir2 for comparison of equality? So here's the thing with is. Is not checking if the values are the same. Is checking are they the same object? And strings are actually cached in all sorts of crazy ways. So it's really a bad idea to use is when comparing strings because you're going to get yourself into all sorts of trouble one of these days. You should use, if you want to compare string or you want to check if strings are the same, equal, not is. Or you can really like get you in trouble. Okay. Sorry, I'm now like going through these questions. So here we are. I answered the question from Kavindu about greater than, less than. I hope that helped. Is A greater than B, false, A less. Oh, I hope that, like, I didn't answer directly, but I hope that helped. Rajitha asks, is it wrong to use, I guess, the triple quoted strings? Oh, for documentation. Oh, I see. Like, I'm getting this now. Got it. Oh, someone's going through and marking what I answered and what I didn't. Wow, that is service. Thank you, folks. Okay. Let's do one last thing here with strings, then I'll take way more questions, whatever people have, including I'll get to Rajitha's question about putting values in the dictionary. So here's the thing. Strings are sequences. And like lists and tuples, not stuples, those are the dumb tuples, the tuples. Strings are sequences, meaning that they can be seen as containers for data, not just simple data structures themselves. And so, for example, let's do this. S equals A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So if I say here, for example, is J in S, we can search in S for J. And sure enough, it's there. But we can also iterate over a string one character at a time. I can say here for one character in S, print one character. And guess what I get? All the letters printed. Now, sometimes people will say to me when I show this example, oh, you're getting one character at a time because you called your variable one character. No. That's not how it works in Python. The for loop turned to S and said, are you iterable? The answer is yes. So then it says, okay, if you're iterable, give me the next thing and the next thing, the next thing. And one at a time, we get each of the characters. The string is in charge. We get one of the characters at a time from string at a time, right? Because the string wants to give us one character at a time. Every data structure can decide what it gives us in a loop. So a string gives us one character at a time. Lists and tuples give us one element at a time. Dictionaries give us one key at a time. Sets give us one element at a time. So it's totally up to the object, not up to us. So you can totally, iterate over a string. And it's common to do that, right? You might want to iterate over it because it has different digits or it contains different things you want to try or check. Well, what if you only want to iterate over it? Like you only want to iterate over every other character. So how can I iterate over every other character in a string? Now, in other languages, I would update the index to have a step size of 2, not just 1. But we'll use a slice. And a slice looks like this, S, from the start to the finish by 2. So this means from the start through the finish, step size of 2. And that's what I get. I can also say, of course, S of 10 until 20 if I really want, or S from 10 until 20, step size of 2. There are lots of different ways to use slices. But because I don't have the index, I have to be a little sneakier. So I can say here for one character in S start finish 2, print one character. And now what have I done? Now I'm printing each character in the string, or every other character, let's say every other character in the string. And it works just fine. I'll say just one last thing, and then I think we're going to take more questions. So basically, Python strings handle Unicode. So it used to be, back in Python 2 days, that if you used English, great. If you did not use English, not great. And now in Python, we handle characters. We can do characters in Unicode, whatever you want. So if I say here, S equals A, B, C, D, and I say, what's the len of S? Not a surprise, it's 4. And what's S of 0? A, S of 1, B. This did not work with non-Latin characters in Python 2. But in Python 3, if I say here, S equals, and I'm in Israel, so I will say hello, I will say shalom. And so if I say here, what's the len of S? Oh, it's 4. And you might think, well, duh, I can't read this maybe, but like it's 4 characters. And by the way, those of you who can read it, congratulations, because I'm sure you're reading it from right to left the way you have to. Good for you. In any event, in Python 2 days, it would see this as 8 characters. 8 characters. Why? Because it required 8 bytes. And in Python 2, they were all confused about the bytes and the characters. In Python 3, we care about the characters. And so I can say now S of 0 and S of 1 and so on and so forth. So whatever language you want to put into Python strings, you can. Whatever characters you want to put into Python strings, you can, and it will handle them the right way. Now, Unicode is a big, hairy subject. So, there are all sorts of exceptions and weird things. But for the most part, this works well. All right, I want to answer another question I see here in the Q&A, and then we will open up to any other questions people might have, which is, putting the value for the dictionary. So if you want to, I think what you're talking about, Rajitha, and tell me if I'm wrong, is you want to say we have a dictionary, like D equals A1, B2, C3. And I want to put a dictionary in a string. So I can grab everything, right? I could say here for one key, or you just say one key value in D items. And I can say print, and I'll use an F string here, key value. So I'm going through each of the key value pairs and printing them out. Another way is I could just say print D, right? This is the cheap way out. I wouldn't do that because it's kind of ugly. You can't really work with it in any sort of serious way. All right, but I hope that's what you're looking for. If not, let me know. Oh, Regina, wow, you're full of questions today. I love it. I love it. We can do almost all the action of range through indexing. What's the special ninja of range? Fantastic. Okay. So if I say for one character in ABCD, print one character. In other languages, especially like in C, the way that I do this is I find out what is the length of the string, and I have my index go 0, 1, 2, 3. And when we hit the top index, we stop. So you might say, oh, we can do that in Python also. I'll just say here for I in, well, not range, in for print S of I. Something like that. We'll say here S equals ABCD. This is like the C-like version of a Python loop. Right, so I'm going to start with S equals ABCD. I'm going to say for I in 4, and I'm going to print this out. There's just one problem. It's going to die a horrible death. And that's because integers are not iterable. The for loop turns to, 4, and says, hey, 4, are you iterable? And 4's like, what are you talking about? I'm an integer. So the reason we have range is so that we can do this. So I can say range of 4, and now it's fine. And the range of 4 goes from, range 4 goes from 0 through 3. So it's up to and not including 4. All right. Tahara says, is there anything we should be considering in terms of performance if we are modifying operating on a large number of strings or a large string in a document, for example? So I'll tell you, normally I am not the kind of person who cares much about performance because I think people think about it way, way, way too much and way, way, way too early. But it is true that you can get yourself into trouble because strings are immutable. So watch this. I'm going to say here, S equals that. And then I'm going to say here, then I'm going to say this. I'm going to say for I in range, let's call it 100. S plus equal stir of I. So I'm going to add 0, then 1, then 2, then 3. In fact, let's do this. I'm going to say stir of I plus space. Will this work? Absolutely. And now S is all of these strings together. So you might be saying, well, that's fine. That worked really well. This is a terrible thing to do. Don't do this. Because plus equal on a string creates a new string. So I just created 100 new strings, right? So I've got, and watch this. We can see what it looks like. If I print it out here, print S, look at what I'm getting. And it's creating all of these strings. Now, if it's just 100 of them, who cares? But I did a project a number of years ago where I had several 100,000 things like this. And granted, it was many years ago, so computers were not as robust as now, but it used a lot of memory and took a lot of time. It was very bad. So it's much, much better, instead of plus equaling on a string, much better than that is to do append, like add something to a list, and then just append to a list, and then do a join at the end. If I were to do that here, in fact, watch this. I'm going to check the timing on this. Probably won't matter that much. I'm going to do this. So yeah, fine. I'm going to say here def, plus equal strings. Okay, watch this. And I'm going to say here, percent time it of plus equal strings. I'm going to check to see how long it takes to run this. Think. Oh, it's taking a while. Actually, it does many iterations of this, so we can find out on average how long it takes. Okay, so on average, this took 15.3 nanoseconds and did a lot of loops. I'm not going to change this. I'm going to say here, append strings. So now I'm going to say, watch this. I'm going to say, let's say output equals a list. And I'm going to say here, output append stir I. And then I'm going to say here, S equals space join of output. Now I'm going to run this. I'm going to say append strings. So you see what I'm doing here? Now I'm creating a list, and I'm just appending to the list and then doing join. If all goes well, this will take less time. I have not checked this, but it should. It'll definitely take less memory, but I hope it'll take less time also. All right, thinking. Okay, and it took longer. Oh, well, I'm guessing that if we did it like more times, then it would be better. But my impression is like, and I was stuck on a problem like this, you should not do plus equal on strings, right? But like, what if I do like, okay, I'm just going to do this here. Yeah. Anyway, if you have any more questions, I'm going to run this like now just to sort of see how it works. But if anyone has any more questions, I'm super happy to answer them. I think I answered all the ones I've gotten so far. Questions, anything? All right, this ran 16.1. I'm going to run. Oh, no, I didn't want to stop that. Stop. Let's make this the same number. Maybe, just maybe, if we do it more times, it'll be slower with the plus equal. I know it takes more memory, as I said. I'm just now I'm really curious. This is the sort of thing I always loved learning about. All right, still taking longer. All right, so I was wrong. Oh, well, there you go. Any other questions, folks? All right. Well, I hope you enjoyed this. I hope this was interesting and fun for you. I'm very grateful for the invitation to come talk to you folks. One of these days, I definitely want to get to Sri Lanka. I've heard it's really beautiful, and I drink lots of tea. So, like, I'm pretty sure, like, you're good on that. Anyway, let me know if you have any more questions. I'd be delighted to come chat with you folks again, and do be in touch. I'm on Twitter. I'm on LinkedIn. I'm on YouTube. I have books. I have a newsletter. Yeah, I'll do the free advertising now for my newsletter. You can definitely look at, if you go to betterdevelopersweekly.com, I'll put this in the chat. So this is my free weekly newsletter about Python. And, I guess I have to put that in the chat. All right, there we go. And I've got about 25,000 subscribers, and you can definitely, like, every week, I write a new newsletter about Python and software engineering. Thanks so much, folks. This was great. I hope to see you again soon. Be in touch, please.
All right. Thank you, Roman, for that. That was really a very interesting session. I mean, you caught me off guard at the start itself. I didn't know Python text created sounds. That was actually a new thing for me. And, the documentation thing, really a new avenue to think about using triple quote for documentations. All right. So that's a beautiful precursor, Ruben, for our future sessions as well. So thank you very much for taking your time and coming to do this session with us. Hope everyone learned something about Python and working with text. So yeah, I think we can wind up the session and stay tuned. We'll let you know what our next session would be like and when it will be hosted. Yep. Thank you, everyone, and have a nice day.
Fantastic. Thanks. You too, folks. Bye bye.